Alright, I'm going to explain how to do problems like numbers 12 on your practice tests. So we are finding possible coordinates to make similar figures, and I want triangle ABC to be similar to triangle XYZ. So you are to give me both possible coordinates to make that happen. So the first thing I want to do is find the scale factor. And to do that, I need to look at the way I named these. So BC and YZ are in the same spots the way I named the triangles. So that means BC is 3 and YZ is 1. So my scale factor can be considered either 3 over 1 or 1 over 3. It doesn't matter which way you consider it. So I'm going to say that the scale factor is 1/3. Now, if that's true, since AB and XY are in the same spots, I look at how long AB is, and that is 6 units long. So I take 1/3 of 6, which is 2. So that means that XY is 2 units long. And I also know that angle B and angle Y have to be congruent. Since B is a right angle, that means that Y has to be a right angle. So that means I have to go 2 units from Y to get my coordinates. So I could go 2 units to the left of Y, and I could call that my X. And if I connect them, I have a similar figure to ABC. But I also could flip that over, and I could go 2 units the other direction. I could call that my X. So I would have this triangle, which is also similar to triangle ABC, because the right angles are at B and Y. So both of those are possible. So my answer, one possible answer is 1, 2, 3, 4, 5, 6, 1, 2, 3. So one possible answer is 6, 3. And the other, 7, 8, 9, 10, is 10, 3. So either one of those would work. So I'm supposed to list both of them. Those are my answers. Let me try another one with you. Okay, I am going to try to find the coordinates of R that would make triangle ABC similar to triangle PQR. So I'm going to first find the scale factor, and AB and PQ are in the same spots when I name them, so that means I can find the distance. This is 6, and the distance from P to Q is 12. So that means my scale factor is 12 over 6, which is 2. So I know everything has to be twice as big. Now the problem is we don't have any horizontal lines to measure the distance from B to C. It's diagonal. So instead, what we're going to do is we're going to look at the relationship between B and C. How do I go from B to C using vertical and horizontal lines? So I go down 2 and I go over 3. So from B to C, I go down 2 and over 3. So since my scale factor is 2, I know everything has to be twice as big. So if I'm going down 2 from B to C, that means from Q to R, and the reason I'm picking Q and R is because it's in the same spot as B to C. So from Q to R, I'm going to have to go down, instead of 2, I have to go 2 times 2, because it has to be twice as many. So I have to go down 4, and then instead of going over 3, I have to go over 2 times 3, so I have to go over 6. So from Q to R, I have to go down 4 and over 6. So let's go ahead and plot that point. Down 4 and over 6 gives me that point there. Now again, I have that figure that's similar, but I have another option. We could take that figure and we can reflect it. So I could go down 4 and over 6 either way. So to get the other one, we still have QP here, and then from Q to R, I would go down 4 and over 6 the other way. So I would be right here. So this is another possibility for R. And those are your two answers. So let's go ahead and write the solutions. So R could be at 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So R could be the 0.65, or the other R is at -1, 5. So -1, 5 is another option. So that should give you a better idea on how to do the practice test number 12.